So inverse trigonometric functions. Okay. So if you see here, I am taking y is equal to f of x be any function and x is equal to g of y, any other function. Y is equal to f of x and x is equal to g of y. So are any two functions, these two functions are said to be inverse to each other. Inverse to each other. What is the mean by that? If I take the function f from a to b, a having x and b having element y. So here clearly if you see here, the domain belongs to x and the codomain belongs to y. Nothing but the image of x will be y. F image of x will be y. So this can be written as f of x is equal to y. F of this x becomes y. Nothing but f is a function from a to b can be defined as f of x is equal to y, where x belongs to a and y belongs to b. So if I consider the function g is a function from b to a, g is a function, g is a mapping from a to where b to a. So if you take like this, okay, b here a g is a function b having y and a having x. So G is a mapping from B to A, then this can be written as G of y. Here f of x is equal to y in the same way, G of y is equal to x. Again same, x is belongs to A and y is belongs to B. So these are the two functions I defined. So then these two functions are said to be inverse to each other. Inverse to each other. Let us see here. The composite f circle g of x can be written as, okay, so f of g of x clearly is equal to, we get x. I will explain you the function concept very clearly. I am going to explain you. Okay, so this is called composite, right? Then G circle f of y. Sorry, here y, because G of y, you should take y alone. Y alone. Finally, we get y. So f nothing but f of x alone you can take. So f is a function from a to b. So what is the input? Input is x. The output is y. Output is y. So in the same way here, g circle f of x can be written as g of f of x. So this is also can be written as x. So where, so what do you observe here? Here clearly when this g and f will be cancelled, here g and f will be cancelled. F and g will be cancelled, g and f will be cancelled. Finally we get x. Nothing but the two functions are inverse to each other. Inverse to each other, right? So yeah, this can be written as G is equal to F inverse and F is equal to G inverse. Nothing but the functions are inverse to each other. Like in matrices already we have seen that A into A inverse is equal to I, or else AB is equal to I nothing but identity matrix. So the product of any two matrices are equal to identity, then these two matrices are inverse to each other. Here also in functions, x in the sense I of x, identity function. Okay, identity function here, y nothing but y can be written as I of y. I is the identity function. Okay, so we can
Sir, what
represent
is
it.
FOG, sir? FOG of Y.
Yes.
What is FOG of Y, sir?
Oh, that is F's a composite functions. F circle G and G circle we can call as F circle G. Circle G. So the relation between two functions that we will discuss very briefly in the relations and functions. Okay, just you have to remember I'm explaining that inverse. Simply remember like that f into g of y, g into f of y. So both are inverse to each other, then get cancelled. Finally, we are going to get uh, the element alone. Like you can take fg is equal to I, g, f also is equal to I, because you know the product when the product becomes is equal to y, So your G can be written as F inverse. See here, if I replace G is equal to F inverse here, what will happen? F into F inverse of Y is equal to, get cancelled, Y. Y nothing but, this is actually I of Y, identity function, identity function. So it may be algebra, it may be like matrices, whatever the concept we can take. Okay, the product of the two function is equal to, like it may be identity matrix or identity function or unit. For example, in algebra, if you see that x inverse is equal to 1, one is the identity. Okay, one is identity here. In matrices, identity matrix. In function, identity function. Okay, so like that we can consider. So we will discuss that circle, but just remember that what is inverse? The product of two functions is equal to identity function, then we can say that inverse to each other. Just to understand its purpose, okay, they don't ask any definitions here, so just you can keep in your mind. Okay, fine. So inverse function, what will happen if you see here also, f is a function, from a to b, but g is a function from b to a. So domain of f becomes codomain of g. Codomain of g becomes domain of uh, codomain of f becomes domain of g, like inverse. So then only it is called inverse. So remember that the function must be 1 1 and on 2. So given function must be 1 1 and on to f is must be 1 1 and on to, then only g is existing. Okay, we can define from g is a function from b to a. So the product of two function becomes an identity function, then we can say inverse to each other. Simply remember that. Okay, and especially in inverse trigonometric functions, you have to remember the properties. Properties are very, very important. Nearly there are 10 to 12 properties are there. There are 10 to 12 properties are there. Mostly we written the properties. Am I right? So yesterday we written almost 2 to 3 properties. Today I am going to write few more properties. Right. Okay. Look at here. The first property. Yesterday, how many properties we written? Sine inverse of minus x, cos inverse of minus x, tan inverse minus x. So all inverse we written, and sine inverse of 1 by x, cos inverse of 1 by x. Okay, tan inverse of 1 by x. What is tan inverse 1 by x? Cot inverse x. Sine inverse 1 by x. What is sine reciprocal? Cosecant inverse x. What is secant 1 by x? Secant inverse. Secant reciprocal is what? Cos inverse x. Okay, cos inverse x. Like whatever the function you can take. For example, tan inverse x, tan inverse 1 by x is equal to cot inverse x, because 1 by tan becomes cot. Like that you have to remember. Okay, fine. And I'll write a few formulas here. You have to remember that. So since we know that what is sine 2x formula, sine 2x formula. 2 sin x into cos x. Am I right? Am I right? Sin 2x formula already you studied.
Yes, sir.
Okay. I want to take here, I want to take here uh, 2x is equal to some sin inverse uh, theta, or sin inverse x is equal to, I want to take, like, let us consider x is equal to sin inverse x. X is equal to sin inverse x. Otherwise theta. Simply I'll explain. Now I am going to derive the formulas, derivation part. As a JEE student, you must derive each and every formula. I need to write it directly also. What is 2 sine inverse x? 2 sine inverse x is equal to the sine inverse of 2x into root over 1 minus x square. Okay. So 2x into root over, this is the formula for 2 sine inverse x, and a 2 cos inverse x formula can be written as uh, cos inverse of 2x square minus 1. I may write direct formulas, but you can be able to remember. Nearly there are 30 to 40 formulas are there. Almost 30 to 40 or 30 to 50 formulas are there. Okay. Sometimes it is quite difficult to remember. You should not remember. You should not by heart. So try to derive each and every formula. Okay, how to derive? I am going to tell you shortcut with it. This sin x can consider some other variable. That's your wish. Okay, sin x is equal to, I am taking theta. Okay, sin x is equal to theta. When sin x is equal to theta, which implies what is x value? Sin inverse theta. Am I right? Okay, sin inverse theta. Okay, substitute here. To this x value substitute on both sides. Okay, look at here. When sin x is equal to theta, then what about the cos x? What about the cos x? Cos x can be written as root over 1 minus sin square x. Yes or no? Sin square plus cos square is equal to 1. Cos square is equal to 1 minus sin square. Then cos is equal to root over 1 minus sin square. I apply this property. So from this cos x is equal to, in terms of theta, 1 minus theta square. 1 minus theta square. Okay. So instead of theta, it's better you can take y. Now that time you can becomes y you can take here y square. Look at here. So now substitute all values here. So sine of 2 into what is x value? X value sine inverse y. This is equal to right side is what? Right side 2 sin x. Sin x nothing but y. What is cos x? Cos x is root over 1 minus y square. Am I right? Am I right? So which implies this side value you can take right side. 2 sin inverse y is equal to 2 sin. Sin you can take, this is right side. Sin you can take right side, that will become sin inverse. Sin inverse of 2y into root over 1 minus y square. Okay. 2y into 1 minus y square. See, so here y is there. In place of y you can take x, you can take theta, whatever you can take. So I proved, I am using sin 2x formula. I proved that 2 sin inverse x is equal to sin inverse of 2x into root over 1 minus x square. Okay. So remember that, take sin x as y, sin x as y. So substitute in place of, then which implies x is equal to sin inverse y. Okay. Then after substitute all the values here, then this side you can take right side, this sign becomes sin inverse, sin inverse. Okay. Sin inverse of 2y minus root over. So how can you prove this? 2 cos inverse x is equal to cos inverse 2x square minus 1. Let's see here. See, what is cos 2x, 2 theta formula? It's better to remember cos 2 theta. Cos 2 theta is equal to 2 cos square theta minus 1. Am I right? Okay. So I am going to derive this part like 2 cos inverse x is equal to cos inverse of 2x square minus 1. 2x square minus 1. That's it. This cos becomes here. Cos be 2x square minus 1. Okay. Let us, for that what to do? This cos theta is equal to, let cos theta is equal to x, which implies what is theta? Theta is equal to cos inverse x, right? Now this theta value substitute here, right? So cos 2 theta, theta means cos inverse x is clearly equal to right side 2x square minus 1. I substituted in place of cos theta x here, x 2x square minus 1. I replaced in place of theta cos inverse x, cos inverse x. Okay. Now, which implies this cos you can take right side. So 2 cos inverse x is equal to cos inverse of 2x square minus 1. So 2 cos inverse of x is equal to cos inverse of 2x square minus 1. So what is the advantage of these formulas? You know, in exam, in integration, especially in calculus, if they want to differentiate, for example, I want to find the derivative d by dx of, for example, this sine inverse of 2x minus root over 1 minus x square is there. Easy to, is it easy to differentiate? No, it is too difficult. But if you know the formula like this, okay, sine inverse of 2x into root over 1 minus y square as like, if you remember this formula, this can be written as d by dx of 2 sine inverse x simply. 2 is a constant, take outside. So that sine inverse x is root over 1 minus x square like that. So very, very advantage is there. Not only differentiation, integration, the major part is there. So integration is one of the most important topic in calculus that you know very well. Okay, applications of derivative and integration. So every year, 1 or 2 questions asking from applications of derivative, 1 or 2 questions asking for integration. Continuity differentiation, that is different. Okay, so to find the derivative, to find the integration, so you should remember the inverse. I told you very clearly in calculus, which is play very important role. Okay, right. So like that you can, not only this, you can derive like tan 2 theta. What is tan 2 theta formula? Tan 2 theta is equal to, what is the formula? 1 is anyone? 1 minus or 2 tan theta by 1 minus tan square theta. Yes or no? This is the formula. So actually what is the formula is there? 2 tan inverse x is equal to tan inverse of formula. Can anyone tell that? What is the formula of 2 tan inverse x is equal to 2x? 2x by 1 minus x square. 2x by 1 minus x square. Clear? So like that. So what to do? How to convert into this formula into inverse trigonometry? Again same. This tan theta value. Tan theta you can take as x. So which implies theta is equal to tan inverse x. Right? Tan inverse x. So then substitute the value. This tan if you take right side 2 theta is equal to 2 theta is equal to tan inverse of 2 tan theta by 1 minus tan square theta. Now we can replace the values. So 2 tan inverse theta value means theta value tan inverse x, 2 tan inverse x is equal to tan inverse of. So what is tan theta? Tan theta I am taking as x, 2x by 1 minus x square. 1 minus x square. Easy. Okay, so 2 tan inverse x formula is tan inverse of 2x by 1 minus. Not only this, we can derive many other formulas also. What are the other formulas? Okay, for example, here 3 sine inverse x is equal to formula is there. Sine inverse of 3x minus 4x cube. Okay, that formula is there. 3 sine inverse x is equal to sine inverse 3x minus 4x cube. How can you derive? How do you know? How can you remember that? It is easy to remember always. No, you can again derive the formula. So we know the sine 3 theta formula. So sine 3 theta is 3 sine theta minus 4 sine cube theta. Am I right? 3 sine theta minus 4 sine cube. From that, what to do here? Again, 3 theta, it can be written as sine you can take right side, sine inverse of. I am taking this sine right side, like right side is 3 sine theta minus 4 sine cube theta, right? Is it okay? I am taking this sine right side, sine becomes sine inverse. So 3 sine theta minus 4 sine cube theta. Now I want to take again x is equal to Like sine theta is equal to, I want to take as x. Then theta is equal to sine inverse x. Okay, I am taking the sine theta, this sine theta as x, then theta is equal to sine inverse x. Substitute here, 3 sine inverse x is equal to sine inverse of, yeah, 3. What is sine theta? X, 3x minus 4x cube. Like that. Okay, like that we can derive in the same way. Can anyone tell that formula for cos 3 theta? Cos 3 theta is, since we know that cos 3 theta is equal to 4 cos cube theta minus 3 cos theta. So what is the inverse trigonometric function formula here? Anyone? 3 theta, 3 will be there na? 3, theta will be there na? Cos inverse x, that is equal to, 4. So cos inverse of, simply replace just cos theta by x, 4x cube minus 3x. It's simple, it's simple. Okay. At a time you may not be remember, you can derive, it will become very easy.
Sir.
For one or two derivative part you might be confusing, but later on it will become very, very easy. My advice is try to derive each and every formula. So not only here, so we written like sine 2 theta, cos 2 theta formula in terms of tan. Okay. So someone is asking like, okay, you unable to see this side.
Yes, sir.
Okay, okay, fine, fine. I can write this side alone, right? Okay, students, that is my advice. So try to derive each and every formula. So I am going to write remaining formulas. So I already written this is 2 sin inverse x, 2 cos inverse x, 3 sin inverse x, 3 cos inverse x. Okay, so 2 tan inverse x, 2 tan inverse x. Okay, fine. Look at here. So 2 tan inverse x is equal to, this can be written as 3 ways. I already written tan inverse of 2x by 1 minus x square. So not only that, it can be written as sine inverse of, what is sine 2 theta formula in terms of tan? In terms of tan, 2 tan theta by 1 plus tan square theta. Am I right? Sin 2 theta is equal to tan theta by 1 plus tan square. So same 2 x by 1 plus x square. That's it. Okay. And 2 tan inverse x is equal to cos inverse of. Okay, what is cos 2 theta formula in terms of tan? 1 minus tan square by 1 plus tan square. Yes or no? 1 minus tan square by 1 plus tan square here, 1 minus x square by 1 plus x square. That's it. This is the 2 tan inverse. So 2 tan inverse. So 2 tan inverse x, 3 formulas are there. You should remember all 3 formulas. Okay. So in the same way, what is tan 3 theta? Tan 3 theta formula, anyone? 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. Is it right? Students. Okay. Now, which implies, so if we converted into like inverse, so 3, you can take tan theta is equal to, x, simple. So 3 tan inverse x is equal to, 3 tan inverse x is equal to, this tan take right side, tan inverse of simple formula 3x minus x cube by 1 minus 3x square. 3 plus tan theta by x, that's the formula. So that is the formula, right? So if you remember trigonometric formulas to converse inverse trigonometry, very easy. So not only that, what is sin A plus B formula? Sin A plus B.
Sin A cos A.
Sin A, cos B plus cos A sin B. Am I right? So now
Yes, sir.
sin A plus B is equal to sin A cos B plus cos A sin B. Sin A cos B plus cos A sin B. This, if I take this sin A as x, sin B as y, sorry, then if I convert it into in terms of only sign here, what will happen? Shall I write this sin A plus B formula? Sin A plus B is equal to sin A cos B. Cos B means, shall I write root over 1 minus sin square B? Am I right? So cos A means, shall I write here 1 minus sin square A into sin B? So completely I converted into sin. Sin A plus B is equal to sin A cos B plus cos A sin B. Cos B can be written as root over 1 minus sin square. So cos A can be written as root over 1 minus sin square A. So now I want to take the sin A is equal to x and sin B is equal to y. So when sin A is equal to x, look at here, all of you. I'm not writing direct formula. Again, if I write directly, you might be confused. So take sin A is equal to x, sin B is equal to y. So A is equal to sin inverse x. B is equal to sin inverse y. Now, if I take this sin S, right side, what will happen? Right side is what will happen here? When I take sin right side, sin inverse. I'm writing here sin, take right side, sin inverse of what is sin A? Yes, what is sin A? X root over 1 minus what is sin B? Y plus root over 1 minus x square into y. So what is left side? Left side, when I take sin right side, remaining value A plus B. What is A here? Sin inverse x plus sin inverse y. Okay, so finally remember formula sin inverse x plus sin inverse y is equal to sin inverse of x into root over 1 minus y square plus root over 1 minus x square into y. Simple. Is it clear? So like that, very important. So in exam they may ask integral. What is the integral of sin inverse x root over 1 minus y square plus root over 1 minus x square into y? They may ask integral. Can you integrate? No, it is not a standard function. There is no any formula for this. But if we know this, integral of this nothing but integral of this, integral of sin inverse x, direct formula is there. Okay, integral sin inverse y, direct formula will be there. Now this time it will become easy. Okay, so try to derive all the formulas. Then in the same way, if you see that cos A plus B is equal to cos A cos B minus sin A sin B. Okay, so from this C cos you can take right side A plus B is equal to cos inverse of cos A cos B. Now sin I want to convert completely in terms of cos because it's depending on the left side value. It's depending on the left side. What is left side? C, nothing but cos. What is the left side? S, nothing but sine. So that this cos terms I change it to sine. So here left side is cos, so that this sine terms you can change it to in terms of cos. Sin A can be written as root over 1 minus sin square A. So root over 1 minus sin square B. Am I right? Now if I consider this cos A as x cos, sorry, this is what? 1 minus cos square A, 1 minus cos square B. Sin A can be written as root over 1 minus cos square, sin B is. So now cos A is equal to x, cos B is equal to y. Then what is A? So cos A is equal to x. Then A is equal to cos inverse of x. Then B is cos inverse of y is equal to cos inverse of what is cos A? X y minus root over 1 minus x square root over 1 minus y square. Simple formula, simple derivative part. Okay, convert right side all values in terms of left side cos. Then after cos A value take x, cos B value take sy. and simplify. This is the formula for cos inverse x plus cos inverse y in the same way. So you have to find the formula for tan a plus b. Okay, tan a minus b. Tan a plus b formula, tan a plus tan b by 1 minus tan a tan b. So from that, can you able to find tan inverse x plus tan inverse y? Yes. Okay. So tan of a plus b is equal to tan of tan of s tan a plus tan b by 1 minus tan a tan b. If we convert it into inverse trigonometry, then if I take tan a is equal to x, tan b is equal to y, x, y, here tan take right side, so that is tan inverse of x plus y by 1 minus xy. So left side is remaining a plus b, a nothing but tan inverse x plus tan inverse y. That's it. So tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus. In the same way, tan inverse of x minus tan inverse of y is equal to tan inverse of x minus y by 1 plus xy. Nothing but here, what is the formula I want to use? Tan a plus b for a minus b formula. So tan a minus b, a minus b, this is a, this is b. So tan a minus tan b by 1 plus tan a tan b, like that. Okay, so these are the formulas. So you have to remember. Next, is it clear? Or any more doubts you having in derivative part? I think so. No. Am I right?
No doubt, sir.
Okay, right. So you should need the derivative. You must do the derivative. Don't buy her directly. If you buy it, you may remember like 1 week, 10 days, 15 days. You cannot apply this applications in exam. So you must be derived. If you derive, so you can easily remember entire year and you can easily apply this application in exam, right? Okay, fine. Next step. That already we have seen that sine inverse of sine x, sine of sine inverse of x. So everyone must remember sine of sine inverse x. Yesterday we written, for example, tan of tan inverse x is equal to what? It is x. Okay, and what is here x? X's domain is what? Anyone? What about the domain? Domain of tan inverse. Yesterday I have written very clearly. Yes. So without knowing domain and the codomain of trigonometric and inverse trigonometric, so you cannot don't go for further steps without knowing. Okay. So you must be remember. You must be remember. Don't bad just analyze that graphical representation. Okay. So that is capital R. So tan inverse of tan x also becomes, both the cases get cancelled. Here also x, what about x here? X belongs to what? What is the domain of tan x? Tan x domain r minus yesterday I have written 2n plus 1 pi by 2, n belongs to z. So graphical representation. In inverse trigonometric chapter, the second exercise is deleted. Actually, that is deleted portion in last year. But this year, we need to discuss that. Okay, we should discuss. So, what is the like first question and second exercise? Two more properties are there. We will discuss all the properties. Okay, 2.2. So, what is the first question? Anyone? The first question is, Prove the following. Okay. Prove that following. Right. The first question is 3 tan sine inverse x is equal to sine inverse of 3x minus 4x cube. Already we proved. Second question is 3 cos inverse. That is also okay. Let us prove that second question. We can do the first. Already we proved. Once again, we will do that. The second question. A second question is prove that 3 cos inverse of x is equal to what is formula? The first two questions they given formulas. Okay, so cos inverse of 4x cube minus 3x. So what is the domain here? X is belongs to 1 by 2 comma 1. X is belongs to 1 by 2 comma 1. So everyone remember that in advance, in JEE advance, you should observe what is the domain they given. Okay, so very logically they'll give. So you should observe the domain, right? How to prove that here 3 cos inverse x is equal to cos inverse of 4x cube minus 3x? Simple. I am taking RHS. I am going to prove that LHS. So what is RHS? Cos inverse of 4x cube minus 3x. Okay, right. In this equation, I want to take like some x is equal to some cos theta, your wish. You can take x is equal to cos theta or x is equal to cos y, cos z, whatever it is. So which implies what is cos inverse x is equal to theta. This cos you can take left side, cos inverse x is equal to theta. Okay, so if I substitute the x value over here, in this x value in RHS. So now RHS clearly is equal to cos inverse of 4x cube, 4 cos cube theta minus 3 cos theta. Am I right? I substituted x value. So which is equal to cos inverse of, since we know that, so what about this formula? 4 cos cube minus 3 cos theta becomes, what is formula? Cos 3 theta. Am I right? Cos 3 theta formula. Cos theta is 4 cos cube like. Now since we know that cos inverse cos get cancelled, finally we got 3 theta. What is theta we got here? 3 theta means 3 cos inverse x. So this is the required LHS. Therefore LHS equal to RHS. I am taking RHS. I proved the LHS, then it is equal. Clear? In the same way you can do the first one. Okay. Third and fourth also you can try. Third question, what they given, tan inverse 2 by 11 plus tan inverse 7 by 24. So the question of third will do, and fourth you can try. Just 2 minutes for this question. Look at here. Third question is prove that tan inverse of 2 by 11 plus tan inverse of 7 by 24 is clearly equal to tan inverse of, right side is what? 1 by 2, simple 1 by 2. So take LHS here. Now we can take LHS. So what is LHS? LHS is, I'm taking. So LHS in the form of tan inverse x plus tan inverse y is equal to what is formula? Tan inverse of tan A plus B. So tan inverse x, tan inverse, what is A plus B? Tan A plus tan B by 1 minus tan A, tan B, like tan A, tan B nothing but x. Tan A plus tan B by 1 minus tan A, tan B. So what is x value? X value is 2 by 11. Y value is 7 by 12. So substitute in this formula. So LHS in the form of tan inverse x plus tan inverse y. So that is equal to tan inverse of x plus y. What is x value? 2 by 11. What is y value? 7 by 24. by 1 minus 2 by 11, 7 by 24. So what is LCM you want to take? I want to take LCM as 11 and 24, 2 into 24 plus 7 into 11 by 11 into 24. In the same way, denominator also, I want to take LCM as 11 and 24, 11, 24 here, 11 into 24 minus 2 into 7, 14. So 11, 24 get cancelled. Now we can simplify. What about the value here? Tan inverse of what? Numerator? 2 into 24, 40, 8 plus 77. Yes, anyone? Fastly. 77 plus 48. 75 plus 15.
Sir, 125 by 2.
125. Then what about denominator? Is it 250 or not? 11 into 24. 264 minus 14. 250. So this is clearly tan inverse of 1 by 2. We proved. Okay. So we proved that. Okay, students. Having any doubts, you can ask. Otherwise, so we can wind up the class.
Thank you, sir.
Yeah, okay.
Sir,
Thank you, sir.
sir,
Yes.
why